So let's now focus on the code base. As I said, we will start with the integration tests, here implemented as RSpec request specs. The basic use case is very simple. When there is an empty list of participants, this is all about registering participants for the workshop editions. Just want to, let's imagine, want to have some kind of UI for displaying the participants for specific edition, right? So when there is a get for participants, the expected response is an empty array in JSON because nothing was added. But if there was a participant added, with using some kind of hash, so turned into JSON later, and if we get the participants, we should see expected response with the same JSON. So we assume this is JSON based. Maybe there will be some kind of JavaScript UI which does it for us. Obviously, it's super trivial. It can be implemented in just one line of Rails, but that's not the point of the session today. So this is the participants controller. I can show you also the routes just to see that there is nothing else in here. So just get to participants, post to participants. In the controller, we have the index, which just calls the read model. I'll show the read model at the end, .all. And then we have the create action. So this is where we get we assume we get 3 params, actually 4 params. It's the participant UID. We assume the UID is generated from somewhere else. It could be generated here. It's important that it's much easier if database doesn't generate the ID. It's much easier because we don't have to couple the whole stuff with the database. So it's the participant UID, it's the edition ID. So we assume there is some kind of ID for specific edition. So we then group them by the ID. And there is a name and there is an email. Using this main scenario in here, we assume that there is a kind of web form for with the 2 fields, name and email, and maybe some kind of hidden field for the edition. But also the reality of our business process around organizing the workshops is that we don't always get this information at the same time. So this is a form mostly for us once we know it, but also we can imagine situations like the typical use case. Someone buys a ticket for our workshop. We receive information from the e-commerce engine from DPD, but the fact that we know is that someone with this email and this name bought 2 tickets or 1 ticket, but it doesn't have, the buying person doesn't have to be the person who participates, and we want to have the participants in the list, not the buying person. It's good to know who bought it, but it doesn't have to be equal for the participants, and we want to coordinate our communication with the participants later on. So we can have an information that someone was actually registered, but we have no idea what's the name, what's the email. That's why we splitted those actions into 3 different smaller parts. This is debatable. It can be done in one part, but this is the way it was done here. And we use a concept of command bus and commands. The commands are very simple data structures. They're objects, but they could be implemented using struct, dry types, or just a simple Ruby class. And you see we have 3 those commands. And now I can show you, like register participant for edition. It's just a small, simple class which just wraps 2 fields and exposes them as an accessor. The same with assign name, the same with assign email. And again, this is really not the main point whether it's implemented using some kind of tooling like dry types. Maybe it's useful once you want to check the types, make some simpler validations, or you can just implement the validations in the constructor and raise some exceptions. From the bigger perspective, this doesn't really, it's not relevant that much. It's just whatever works for you, go for this. So we are splitting this one web request into 3 commands under the hood. It's also a little bit artificial just to show you how it can work with more than 1 command. What is a command bus? In our case, command bus is implemented in the application controller. It can be implemented in the initializers, for example. It can be implemented in the configuration of the Rails application. It can be also implemented using some kind of dependency injection mechanism you may have. I think Dry, they have this concept of containers, or maybe it's part of ROM, which probably could be used. In our case, we just wanted to make it clear for people less familiar with those concepts so that we can have it in the application controller. Make sure with memoization that it's a one object, initialize it always when it's first access, and that's it. So we have a command bus, and we initialize a command bus which comes with the Rails event store tooling. So today I'm using the tooling which we developed, and it's open source. And we did it so that you don't have to write the boilerplate code again and again. and we use it in our projects, and also many other people also use it. But it's not the point to advertise this tooling here. You can do it whichever tools you like. It's more about the concepts than the tooling. And configuring command handlers is a simple concept. We just say, if a command like register participant for addition happens, we want to be handled by register participant addition handler. That's really not the best name maybe, but it's always one command and one handler. There's no way a command could be handled by two handlers. So when it's a command like register participant for addition, it's handled by one place. So in a way, we are decoupling the intent of the action, registering the participant, from the place where it's actually happening. So you can see now the cost of the splitting, because once you split into two classes, you have to have this kind of mapping somewhere, like who is responsible for handling that. And if we go to register participant for addition handler, it's a very simple class again. So you can also judge that maybe we went too far with those concepts. And in such a simple code, you would be right. But in more complex situations, we see those handlers bigger, and they're a good place for certain logic. So after you get some experience, you actually know that where to put certain logic. For example, the very trivial examples of validation can be put in the handler. Command handlers are more like the facade of the domain layer. So this is like the putting a right, like very clear. This is where the place where we call the domain layer. What it means to call a domain layer. First, let me just note that we are already inside the domain in a module called workshops. We are namespacing a business area. We call it workshops. This is where we track the registering of participants, additions, and so on. So this is what we call workshops. For example, we can have a module called logistics, where we handle things like also addition. So you can see the class like addition would exist here. It doesn't yet exist here, but it will exist in two different areas, two different namespaces as different classes. So this is one way of solving the whole problem of the user class having 50 columns, because now you split the class into smaller, which represent the business concept for different things. So in the logistics, it's important that addition has venue. But in logistics, maybe it's less important how much people paid. That would be more about the pricing or sales banded context. All right, but coming back, so what exactly lives in the workshops? And this is also another good point here. Workshop is actually a top-level directory. That was our choice. This, again, can be debatable. But we wanted to follow the advice of Uncle Bob. Uncle Bob once said, if I open a project, I don't really want to know the main point about that this is a Rails project, and usually this is what you see, app, bin, config, db, lib, this is a Rails project, but you really have no idea if it's e-commerce or what kind of problem does it solve, what's the business area exactly. And actually Uncle Bob compares it to real buildings. If you enter a library, you can see around, oh, I'm in a library, it's pretty clear. If you enter a church, you enter the church and you see, okay, I'm in a church, it's pretty clear to me. While if you enter any kind of programming repository, you open it, you have still no idea. It's not the main point to be so clear about it, but we kind of got this point from Uncle Bob, and it kind of makes sense to me and to us. So we can imagine that those bundles contexts like sales, logistics, ordering, and so on, it would all live as directories in here. So you can quickly jump from one place to another. But also at later points, we can imagine those being extracted as gems, maybe, or separate repos. This is more like about the physical separation, which I covered in another video. You should be able to find it in the Arkansas YouTube channel. This is not like, again, this is the conceptual split and the physical split. In the workshop, we have lib and spec, and so you can see also, we will later show it, that the spec belongs to the bundled context. So when we write tests for a specific unit, it actually lives there, doesn't have to need to know about Rails, for example. Also, what happens here, all this code doesn't know about Rails at all. The dependency is that Rails uses it, but it is not using Rails. So we have the commands definition in here. That was the choice. We have the events definition. We'll show the events later. And we have the command handlers, which we put in one place. And the command handlers, they are just loading the aggregate and run one method on this. That's basically the pattern here. Loading an aggregate, and actually the whole concept of aggregate. This is the important part. An aggregate is like one of the most important places in our application. Aggregates are the things which make decisions. And in our case, there's really not that much to make decisions about because it's a simple application. But I can imagine that maybe we want to not allow registering participants if we're over the limit, because we know the limit is usually 20 slots, because we are limited by the venue, and also we are limited by, we want to focus on people, we don't want to have mass events like 100 people, because we wouldn't be able to help them one by one, each person separate. So right now, applying an event means making a decision that, yes, you are asking me to register for edition. I say, yes, participant registered for edition. I confirm. This is not, now this is a fact, and this is the event. Or now you are asking me to assign a name to the participant. I'm saying, yes, sure, that's fine. Please note that if the name was empty, this is not the place to make these empty validations, non-empty validations. It would be more probably appropriate either at the command level or even better at the controller level to have those very simple validations to say that something is not empty. So in the aggregate, it's more about the business rules, like 20 is the maximum here. Also, this shows, because this is really code we wrote, this also is a nice example, I think, how also we made a mistake, because we implemented those methods on the aggregate. It made sense when we implemented them, but actually register for edition, maybe it's not a method on participant. Maybe we need another aggregate called edition, and then we have edition.register participant. And that makes more sense, because we actually want to keep the invariant that there's at most 20 people at the same time. We want to keep it at the edition level. It's not a rule for the participant. It's more a rule for the edition. So it's not always quite clear. We thought we were the business experts. Maybe we're the domain experts here, but we also make mistakes here. So this will be refactored later to actually exist in the edition. So apply is a method which exists thanks to the aggregate root. This is part of our Rails event store tooling. Participant is event sourced, so those events are not only used for publishing the information so other places can react to it, although that's the main topic for today's session. I will talk about event sourcing probably in another session. But event sourcing also means that we are publishing this, but when we load the participant, and we saw that we are loading the participant in here, loading a participant means, because it's an active aggregate root module used, we can use the load part, and we say take events from this stream, from this event store, and from those events load the participant. And actually what is happening under the hood, just to mention it quickly so that there's no magic for you, what is happening for each of those apply participant register for edition, we have their equivalent methods in here. But right now they don't do anything because we don't really need to skip any state. And we don't need to skip any state because we don't make any decisions based on the state. But we can imagine the additions later on. When there's the addition aggregate, we can imagine we actually want to store a list of participants as an evar. And then we can say if participants.size is already 20, we no longer allow registering, maybe raise exception, maybe publish some kind of events, or return an error code. And then that would mean that in the addition code we would have participants, maybe participant.new or something like that, right? So you can imagine how this would work. For now, this does nothing because we are not really using it. Also, it's because it's a very trivial example. So command intent of change, handler, which handles the intent but calls the aggregate, which is event sourced. So it's built actually every time we build the participant, we actually .new doesn't do anything, it's just a simple constructor. And just load participant means takes the events from the database, from the event store, and event store is just one table of events. In the newer version right now, which we'll be going to release, it will be 2 tables and will be split between events and streams. Still, this is basically loading something that is indexed and should be a quick query. And usually in a typical aggregates, you don't really have situations where one aggregate consists of, I don't know, thousands of events. If it contains thousands of events, then something is wrong with the design. Aggregates should be small, also for the reason that they should be easy to load from the event sourcing. But also there's a technique called snapshotting. So in case you really have those big number of events, you can have a snapshot event and just load from the last snapshot, and that's very easy thing to do. All right, enough about this. So let's go back just to make it very clear what's the flow. controllers, participants, controller. We initialize those three comments. Everything is synchronous here. This is happening line by line, and then we return the confirmation. So we initialize the comment, we pass it to the command bus so that it goes to the command handler. So the command handler is here, loads the participant and calls register for addition, which all it does, it publishes an event. And then it stores the events. Actually, it first stores, then publishes. The order is important here. But the aggregate root tooling does it for you. You don't have to bother about it. And just to be clear, show you schema. In the schema, we have event store events where the migration is generated using the release event store. All is in one table. That's usually, in most cases, good enough. Right, so we are publishing the event. So what happens next, right? We actually didn't really create any kind of state. So how are we going to display this data on the website? We want to have a list of participants displayed, right? Or in our case, we want to expose the JSON, so someone else may want to display it. So what exactly needs to happen? One way, the more like active record way, would be to expose, to actually keep the state here, use evars, and then expose an attribute or a method, a getter publicly so that anyone can take the data and then they can be displayed. But really, in most applications, reads are happening more often than writes. So when I said this is easy to event source, I wouldn't use event sourcing for really for the read parts without some kind of caching. And actually, it's not often the case that what sounds like the same active record model for writing, it's usually actually joined by some other data on the read side, and it's actually a separate concept. This is the part about CQRS, which took me actually ages to understand. But once I got it, why it makes sense, it was like, wow, that I can simplify my code. And the simplification of my code, for example, relies on the fact that my aggregates, they don't expose getters, or at least they expose much less getters than previously with active record models, for example. And this is much easier for testing. I will show you the tests very soon. So it's much easier and simpler to reason about. It's like a black box where you call some public. It loads from events, so events are the input. Then you call some public method, and then it outputs new events. Very simple black box. It's basically a function. Right. So what happens with the event? Let's go and find the usages of this event. This is just inheriting from the Rails event store event, and the usages say that in application controller we are doing something with this, and we are configuring event handlers, and this is where we are with events now. So event was published, and we can configure event handlers, and we use the concept of event store client. This is configured in Rails configuration, and the event store is basically the Rails event store config.event store is Rails event store client. So this is something provided by our tooling. Also, it's worth just noting that we are adding the workshops lib to the path, so that the Rails autoloading still works. And also, we are configuring aggregate root to actually use the same event store that is. So in here is actually event store. All right, so the event store is initialized the same way as a command bus is a dependency. You can extract it somewhere else and configure event handlers. This is subscribing the events, and with events it's different than with commands. Command has one handler, that's a rule. With events you can have, and that's the point, with event you can publish one event, but many places can handle this in whatever, usually whatever order. But in here we're just saying there's one handler which handles 3 events, so we pass a list of 3 events, and we say participants read model handle those. So what is a read model then? A read model is just a simple concept. In our case, it's just a wrapper over the active record class. It wouldn't even need to exist. We could call the active record directly. I just wanted to expose it as a pattern in the code base so that maybe for some people it's easier to understand. Also, we initialize it in the application controller when someone accesses it for the first time, use memorization, and we go to participants read model. And what it does is it's handling the event and delegates to other private methods in the class. But it's actually just a wrapper over the active record class. Participant.create, participant find by, and update, and the same update here. And then at the end, someone uses readModel.all to grab all the data and get the JSON out there. Maybe JavaScript will show it. Or you can use Rails views. It's really nothing. It's not relevant for this discussion right now. So this is what you can do with the events, and you can see the participant is created as a, we actually have the schema. It's actually a participant table. We also have participant as an active record model. We use UID, so this change was required here. But overall, it's just a plain old participant active record. The only difference, well, the main difference here is that we are using the read models without any logic. We just say update the record. There should be no validations at all at the read model level, because we assume that all the data is always correct, because we rely on the events, and events are already happened. This is already true. So we are building those read models just to be quick expose of the data. So for example, I can imagine that later on we want to have actually a read model exposing additions and participants together, so there will be a join. So maybe that will be actually part of this to handle both addition and participant. Even though they will be two aggregates, they will be handled by one read model, but again by two active record classes, for example. So this is where the loop ends. We started with a controller, we created comments, comment handler calls the aggregate publishes event is handled by the read model persists the data, so that when the all method is called, this is just displays, and suddenly the whole loop finishes. I hope you can understand the loop. This is the most important part. So even though we decoupled, at the end it's actually all synchronous. It's all actually fast. There's this maybe perception that new classes are created, but it's all super cheap when it comes to performance. And at the end we just expose the data, and that's it. The next part I want to cover now, this will be about testing the units.